Okay, we're going to start by graphing this parabola, and based on the way number 1 looks, I can tell it's going to open up or down because it has an x squared. So I want to focus on getting the x squared and the y on different sides, and in order to do that, I would do x squared on this side, and 12y would go to the right. And then I want to mimic standard form. Standard form is the x minus h squared equals 4py minus k. That's standard form. So if I mimic that, it would look like this. It would look like x minus 0 squared equals 12, and then y minus 0. So based on that, I can tell that my vertex is at 0, 0. So I can go ahead and also plot that on my coordinate plane. And I'm going to label that with a V. So there's the V for vertex. Okay, the next thing I'm going to do is draw my axis of symmetry. I know this is going to open up or down, so I know that my axis of symmetry is going to go straight through the vertex, up and down. So I'm going to label that AOS for axis of symmetry. And that's straight up and down, and it is through 0, so that would look like x equals 0 as the equation of a line. Then I'm going to find my p-value, because this p-value is going to help me really through the rest of this problem. So if you look, the 12 is in place of the 4p. So if we set 4p equal to 12 and divide by 4, that would mean p is 3. So we know p is 3, we can fill that in. And what that helps us do is, if we count from the vertex, if we count up 3, 1, 2, 3, and we count down 3, 1, 2, 3, that's going to be our focus and our directrix. Now, which is which? Well, p is 3. Since p is positive 3, we know it opens up. I knew it was up or down. P is positive, it opens up. Okay, so that means that this higher blue point, that's the focus. So the focus is at 0, 3. The lower blue point is the directrix, which is a line. So I'm going to dash a line through that, and I'm going to label that directrix. And that would be the equation y equals negative 3. And then the last thing is, to really graph this parabola, we need 2 more points. So we need that lattice rectum idea. So from the lattice rectum, we know that it's 12 units long. And I got that because 4p is the lattice rectum, and in our equation, 4p just happens to be equal to 12. So what that means is that 6 is going to be on one side and 6 is on the other side. So from the focus, I'd count over 6. 1, 2, 3, 4, 5, 6. You're going to see a purple point. That's 6 over. And then I'm going to count 6 the other way, left. 1, 2, 3, 4, 5, 6. That from purple dot to purple dot is 12 units. And I'm going to connect that with my vertex, and that's going to be my sketch, my sketch of my parabola. That's pretty bad, but I hope yours looks better. So that's it. That's really how you sketch it. And then the eccentricity is 1, because a parabola always has an eccentricity of 1. So I'm going to pause this, clear this off, and then we're going to do number 2. Okay, let's take a look at the second example. And this one's already pretty much in standard form. Notice that in this time the y is being squared, so that means that this one must open either right or left. So the first thing we're going to do is get the vertex. The vertex comes from the h and the k. So the h goes with the x value, the k goes with the y value. So in this case, h would be 1, k would be negative 1 because it's a plus 1, and we talked about that with circles. So I'm going to plot 1, negative 1, and I'm going to put a V by it, and that's my vertex. Okay, so that red point with a V under it, that's my vertex. I also know that this opens right or left because of the fact y is squared. So that means that my axis of symmetry is going to run, it's going to run horizontally. The axis of symmetry is going to be horizontally through the vertex. I'm going to label that AOS. That's my axis of symmetry. So the next thing is really finding that p-value once again, because p is going to tell us everything we need to know. So axis of symmetry, let me just write that equation. That would be, let's see, y equals -1. That would be our axis of symmetry. So if we look, 4 is in the place of 4p in our equation. So if we set them equal to each other, so 4p is equal to 4, divide by 4, our p is 1. Notice p is positive, so that must mean if this is right or left, it's going to be right. So our parabola will look something like that, because it's going to open to the right. So now, p is 1, so I'm going to count 1 to the right, 1 to the left. One of those is the focus, one's the directrix. Well, since it opens to the right, the point to the right is the focus, and then I'm going to dash the one to the left, and just right underneath that, that's my directrix. So to connect that red vertex to other points, I need to find the lattice rectum. So first let's fill in the focus. So the focus was at 2, -1. The directrix was that straight up and down line, so that would have been x equals 0, because it's going straight up and down there. The lattice rectum would have a length of 4, because remember it's 4p. 4p is the lattice rectum. So 4 times 1, or that 4 is in its place. So the entire length of the lattice rectum is 4. So what I'm going to do is I'm going to go 2 on either side. Okay, so from the vertex, or sorry, from the focus, I'm going to count up 2, and I'm going to count down 2, because that's going to give that parabola that open right shape. And I'm going to connect like that in the sketch, and that's what my parabola will look like. So P once again was 1, the eccentricity is 1 because it's a parabola, so it always is. And that's that.